Okay, this is the Math 1113 Zoom meeting. It's the meeting I'd hold tomorrow, but can't. Tomorrow is a vacation day, so we're holding it at 4 o'clock today. So the assignments for this week, practice problems, section 6.3, practice problems on page 531, 5 through 17, and 19 to 45. Odd. Again, not for a grade, but we have the quiz on Friday that will be based on them. We'll pull them up. It's about graphs of sines and cosines. So we're going to graph 5 through 17 and 19 through 45 over to here. And the book busts up, there's 6 functions, remember, sine, cosine, tangent, secant, cosecant, and cotangent. Turns out sine and cosine are their own kind of graphs, very similar. And the other 4 are completely different. So we do the other 4 next week in 6.4. Sine and cosine, graphs of sines and cosines this week. All right, WebAssign, personal study plan, practice quiz. Problems 1, 2, 3, 4, 6, and 7 only. Just email me the percent of these 6 problems that you get correct. Okay, let's see if I can explain why sine and cosine are such similar graphs to themselves, but completely different from the others. 6.3 graphs. Y equals sine x and y equals cosine x. A little bit of delay on the Wi-Fi. Okay. Remember, this is y coordinate on the circle. So I'm going to draw the first quadrant. You start off at 1, 0, working your way up to 0, 1. And we're going to take pi over 6, angles pi over 6, pi over 4, pi over 3, and of course pi over 2, and we started at 0. And coordinates, root 3 over 2 and 1/2. Now, in that form, it's kind of meaningless. We need decimals. So a square root of 3, 2 is 0.866 and 0.5. That's what will be useful. The Wi-Fi is delayed today. This is root 2 over 2 and root 2 over 2, and that will be the decimals for those. 7071. And of course, they switch up here to be 0.5 and 0.866. Wi-Fi catch up. Okay, make a table. X is your angle, and Y is your Y coordinate. So in my x column, I have 0, pi over 6, pi over 4, over 3, and pi over 2. This is first quadrant anyway. Y equals sine of x. Okay, so I have 0, 0. First y coordinate is 0. At angle 0, y coordinate 0. At angle pi over 6, y coordinate's a half. Okay, pi over 4, you're up 0.707. 1. Pi over 3, you're up to 0.866. And at pi over 2, you're up to 1. Let the table fill in. All right, I won't have much room for other than this first quadrant here. 0, 0. I'll call this 1, 0.5. Remember, these things are only spared by 15 degrees. So pi over 6, pi over 4, pi over 3, and then you got another 30 degrees over to 90, which is pi over 2. In effect, you got 30 degrees here. Pi over 6 is 30 degrees. Then you got 30 to 45. You got 30, remember these 30 degrees, 45 degrees, 60 degrees. So those are kind of bunched together. Then you got another 30-degree spaced here to 90 degrees. Okay, so when we graph the first quadrant, 0, 0, pi over 6 up to a half. Hey, we're get rid of some of that delay. Pi over 4 up to 0.707. 1, I suppose. And 0.866. Pi over 3. And by pi over 2, we're up to 1. This nice increasing curve. All right, so does it keep increasing? Well, of course not. If you remember what happens, you're going back down to -1, 0. If you redo your coordinates over here, you'd be at -0.5, 0.866. So you can see another 30 degrees over, which would be 2 pi over 3. You drop back down to 0.866. Not going to be able to get this all in one page. Here you're back to -0.7071 and positive 0.7071. Your square root of negative square root of 2 over 2, root 2 over 2. You drop back down to there. Oh, you're dropping back down through these same values until you finally drop back to 0. So if I wanted to, it might be easier to put this on maybe a page like this. 1, And let's see. Actually, I'd rather do it like this, I think, just for the very first one. 0, you got pi over 6, pi over 3, and then finally pi over, I don't know if I can scale it out properly or not. Let's see, then another 30 degrees, you're at 2 pi over 3, then you're at 3 pi over 4, finally 5 pi over 6. Sure, you have all these memorized, and you're finally at pi. So this is from here to here, you're at first quadrant. All right, and then from here to here, you're at second quadrant. All right, your numbers in the third quadrant, I don't know if I can squeeze all this on, would be 7 pi over 6, 5 pi over 4, 4 pi over 3, finally 3 pi over 2. That would be down to your third quadrant. And finally, into the fourth quadrant, you'd be at 30 degrees more. You'd be at 5 pi over 3, 7 pi over 4, and finally 11 pi over 6, and finally 2 pi. And here's your fourth quadrant. I don't know if you can imagine I'll be writing them down. So I've shown you the first quadrant. You're going up. Here's 0.5. It's 1. So you're going up to 1 at pi over 2. Then you're dropping back down the y coordinates to 0 by pi. Well, what do you do into the third quadrant? Well, if you can imagine, your y coordinates are getting, you'd be down -0.5, negative 0.707, negative 0.866. It gets steeper and steeper until you're going to -1. So you're dropping low down to, here is negative 0.5 and -1. So you're down to -1. And then when you go to the fourth quadrant, you're going back up finally toward 0. And so you're at negative 0.866, negative 0.707, negative 0.5, and you're climbing back to 0. And then you're repeating the process again, infinitely. All right. Sorry that my drawing is pretty shallow. That I've labeled that 1, but it looks a lot bigger. I've labeled this -1. They're actually equal. So if I put this on the graph, put this on the calculator, you want radian mode. To graph. And you want to kind of say, if you want to show the graph I've just done, this is like your x min 0, x max 2 pi. You can make your x scale pi over 6, do it every pi over 6. It won't, show all this. So if I go to y equals, and I put in sine x, and I go to window, 0, to pi, let's make it pi divided by 6. And we'll make y mean -1 by 0.5. Okay, so that's the window I'm going to use. I'll write that up here. Graph. Y equals sine of x, radian mode, window, x min, x max, x scale, y min, max, y scale, and I'm using 0 to pi by, say, pi over 6, negative 1, 1.5. Show you again, y equals, is the sine of x, the y coordinate around the circle. Window there. Graph. Goes up to its peak, down through its dip. That is called one period of a sine wave. Up, down, back to the center. It goes up to 1, down to negative 1. This is at pi, halfway through. This is at 2 pi. This is called one period. Sine wave. It repeats infinitely. Both directions. So in other words, I'll shorten it up so I can get more periods on. Try to make it look as even as I can. That's at negative 1. This is at 1. Y equals sine of x, negative 1 to the dip, 1 to these peaks, and one period is the time or distance it repeats. Is 2 pi. Okay, if I wanted to do y equals cosine of x, this is x coordinate around the circle. I don't know how much details you all want, but if you just look real quick, 1, 0, you're going up to 0, 1. You start high at 1 and go down to 0. Okay, go down to 0. This is for cosine of x. It's x coordinate. In other words, does this starts high at 1 with angle 0. This is at pi over 2. If this dip, you're at pi because you're down at negative 1. Over here, remember your coordinates negative 1, 0. And you're back to, this is at 3 pi over 2. And you're here at 2 pi. You're going down here to 0, negative 1. So at 3 pi over 2, you're back to 0. So then I got delay and froze. Please unfreeze. Okay, it did. And then back to 1 and 0. And this goes forever. Cosine starts high, goes low. Sine starts in middle. Okay. I hope that's enough to convince you. I'll do a cosine just to convince you. I'll keep the same ranges and everything, but I'll just switch it to cosine x. Graph. Yep, starting high, down to dip, finish back high again for one period, 0 to 2 pi. Okay. There's going to be some vocabulary. To learn. I'll put up a generic sign with it. This applies to sine and cosine. But I'll just generically show it with a sign. Up, down, up, or back to here. This is, again, one period. The distance up, distance from center to peak is called amplitude. Distance from start to when it repeats. One period. 2 pi. Okay, there could be vertical shift up, and there's also some called, before I get into those, we'll do some examples. Let's see. First of all, just graph. Just graph, and you just graph it on the calculator and write down what you see. We'll start with number 5. This is 6.3 homework. 31, number 5, graph. 2 plus sine of x. All right, I hope you know your shifts from college algebra. This will be a shift up 2. You don't have to have these memorized. In radian mode, y equals 2 plus sine x. Graph. And I'm not seeing anything because I forgot to adjust my window. You got to pay attention to your windows here. So this one's going to run from like 1 to 3, I believe. If I go to window, 0 to 2 pi I can keep. About 1, 3, graph. Now we got it. Okay, it doesn't show you the horizontal center line. But the 0 is going to shift it up. This is going to be centered around 2. One, and then it's going to go up 1 from that to 3, from the center up to 3, down across the center, go down 1 below, back to the center. This is going to be centered around 2. Centered around vertical shift. And it will do this forever. As you, remember this is angle. As you increase the angle, the coordinates just cycle through these values. This is going the angle in a negative direction. All right. It's all supposed to be even. Okay. All right. We can go, say, to 19. Let's show you a formula for this. This is page 525. Give you y equals a sine of kx, y equals a cosine. Applies equally to sine and cosine. And amplitude is absolute value of the a. This is times, wrote it out a little further. And period is 2 pi over the k. For these, this is generalized curves. Try 19. You're supposed to, for y equals a cosine of 2x, graph, find amplitude, and period. All right, I'm going to send it back. Window 0 to 2 pi. I'm going to send it back to minus. There's no vertical shift, so that means you keep it at -1 to 1. Okay, and the formula will be cosine of 2x. Graph. Oops, got a problem. What did I do? Oh, extra parentheses. Graph. Oops, graph. All right, notice I use 0 to 2 pi, and you see how I'm getting 2 cycles. This is still 1 period, but I'm getting 2 periods inside 2 pi. So in other words, the graph means on this one from 0 to 2 pi is going up to 1, down to -1. I'm getting, here's 1 cycle. Oops, no, 2 pi is right there. 2 cycles. Amplitude is still 1, which is 1. There's a 1 in front of there, understood. And the period is equal to 2 pi over the k, which is 2 pi over 2. This is the k value, which is pi. So I'm looking at pi right there. 1 period is pi. Get another full period in at 2 pi. All right, let's see. They give you a bunch of these. They don't really show you the full formula. The full formula is off page 526. Y equals a sine of a k, x minus b, and y equals a cosine, oops, of a k, come on, a cosine of a k, and then x minus b. They don't really show the vertical shift. I like to add plus vs, vs equals vertical shift. Don't know why they won't do that. Now, once again, amplitude is absolute value of the coefficient in front, period, 2 pi over the k, and then horizontal shift equals your B. And it is positive with a minus in the formula. This gets very confusing. Very confusing. The K must be factored out. Okay, let me try another simple one. Another simple one. Like 29. I'll have you fill in a worksheet. Worksheet. All right, so 29. So off page 531. Y equals a -2, a sine of 2 pi x. Here's the worksheet. Amplitude, you're going to fill in. Period. Horizontal shift. Vertical shift. All right. These two are easy. Okay, you're going to match to, okay, you got y equals a -2 sine of 2 pi x. You're going to match to y equals a sine of a k x minus b plus vertical shift. And that's vertical shift. All right. Horizontal shift. Equals 0. Vertically, you tell there's nothing added on in this parentheses. Your k is 2 pi. You got your x. There's no minus b up here. There's no minus. So you're -0 plus 0 in effect. So your vertical shift is 0. So both of these are 0. Your amplitude is absolute value of the A, which is absolute value of the -2, which is 2. Always positive. And your period is 2 pi over the K, which is 2 pi over 2 pi, which is 1. So yeah, you'll see a lot of pi coefficients, and then the pi's will cancel out on the period formula, and you wind up with some sort of whole number. So your amplitude on this one is 2. Your period is 1. And they want a graph. Sometimes I just use -10, 10, 1, -10, 10, 1. Might just do that. I'll just go back to your standard window. Because it's too hard to. A lot of times I like to keep the 0 to 2 pi. Then I might go -3, 3. There's no single correct window on this stuff. If you really want to, I hate to use the word cheat, but if you really want to match what the book has, look in the back of the book and use the book's graph. Because it really is hard to know sometimes what the windows are. Maybe I'll do that on this one. 6.329. Okay, they're using pretty much a 0 to 1. See, there's your 2 for your amplitude, your 1 for your period. They're pretty much horizontal using a 0 to 1. See, there's a quarter, a half, 3/4, 1. Horizontally 0 to 1, and they're going from -2 to 2 vertically. There's your Y min, Y max. So I might do that. Zero to 1 by say 0.5 and -2 to say by 1. Sure, I don't think I've entered the formula. The formula was -2 sine 2 pi x graph. Yeah, that's pretty close to what to look at. Notice this one starts in the middle. It goes down because of the negative on the 2. So what's down is up and what's up is down. So in effect, down, up, and then down for one period. This is 1, here's 0. You're going down to -2 and you're going up to 2. And it would repeat in each direction. All right, why don't we, we're at 40 minutes. Why don't we try one with all the whole shmo? Let's try one like 39. This is, doesn't have any vertical shift, but this will illustrate y equals 5 cosine of a 3x minus pi over 4. And I want to rewrite 5 cosine, pull out the 3. Leave it x minus pi. And if I pull out the 3, I've got to put the 3 down on bottom here, leaving it 3 times 4. So there's a 3x minus, and the 3's a cancel, leaving you the pi over 4. But this is going to be 5 cosine of a 3, x minus pi over 12. All right. Put that over here, 5 cosine 3, and then x minus pi over 12, again, plus 0. Match 2. 5 cosine 3, a, I guess I'm an a, k, x minus b plus your vertical shift. Okay, so that's what I wanted to do. I want to put the letters in. So when I fill in the worksheet, my amplitude is the absolute value of the 5, which is 5. Period is 2 pi over the k, and the k is directly 3. Your horizontal shift equal to b, which is pi over 12. And the vertical shift is easy. Vertical shift is 0. Okay, for a graph, see, I can use these things to set my window for one period. X min, X max, X scale. I'll use 0, 2 pi over 3. And I don't, the scale doesn't matter, 0.1. And then Y min, see, that will show, starts at 0, it shows out to pi over 3. Y max, Y scale. I usually want to go -5 to 5, your amplitude vertically. So it's -5 to 5 by, say, 1. All right, let's see if we can draw a graph of this. Five cosine of, I'll do the original 3 minus pi divided by 4. Window 0 to pi divided by 3. That's out of 0.1. And then -5, 5, 1. Graph. Okay. You can kind of see it's horizontally shifted because the peaks are not at the y-axis back here. Starting up kind of just below the peak, down, and finishing about right there for one period. And that period is 2 pi over 3. You're going up to 5. You're going down to, sorry, it doesn't look that great, -5. We'll check the answers in the book, make sure I've got it right. This was 39. Okay, 5 is the amplitude. 2 pi over 3 was the period. Pi over 12 was the horizontal shift. It shifted by pi over 12. It doesn't list 0 for the vertical shift. There is no vertical shift. Notice it's it's using a scale of pi over 12. So yeah, they did it right at from peak to peak. So those exact details don't matter that much. All right. Hope you like this week. Sines and cosines. Next week we do the other 4. And it completely changes. The other 4 graphs have asymptotes in them because you're dividing out sines and cosines. And therefore you can be divided by 0, creating asymptotes. Hope that's enough to get you started for this week. We'll post this and have another Zoom meeting on Friday. Email me with any questions you might have. All right. Thank you.